Hello everyone. I hope things are audible now. Let's see if things are working fine. Hey guys, am I clearly audible to all of you? Let's see. Yeah, seems to be working fine. Great. So I guess we have few folks to be waiting to be joining in. I'm just gonna quickly just make one message and then we are gonna start. Hi everyone. How is the progress? What's the progress on the workshop as of now? Hey, hi everyone. CSES. Okay, let's get started with the solving part then. Hi. 4 5 problems remaining. I did nothing. Why, Amit? You should try and solve the problems. Even if you are pro, maybe you can try and solve all of them. If you are new, then it obviously makes sense to solve all of them. Will you be solving all the problems in this stream? Yeah, we are gonna solve all the problems. Maybe we will leave out two because obviously one of them is 3DP, one of them is three of them. One is EasyDP, one is Bitmask DP. Rest all we should be able to solve at least in this stream. Okay. I was busy with some work of my 7 problems are pending. Okay. So I think so you were going on the track, but I think yeah, it's fine. Like if you have 7 8 problems pending, it should be good. I added few more. I added few more problems today itself. Two more problems, and there were few things that I guess we discussed. Uh, kind of we'll be doing yesterday. So that those videos I added to the platform itself. You can check them out on the workshop office work. Set your priorities right, guys. How is office work gonna come into solving stuff? Okay, chalo, let's get started with CSES problems, and let me share my screen, and that should be the first part. Let me quickly set up the windows. This is the most boring part. Can we take some doubts at the end? Yeah, we can. Maybe that's perfectly fine. Sounds very reasonable. Let's go into the in-game mode, which is this. Yeah, everybody's able to see my screen, right? Just a quick check before we start with discussing problems. I can make it a bit larger so that you guys can see it very clearly. Everybody's able to see my screen and my question, and the questions are readable, right? How's weekend? Full with streams, guys. Weekends, I didn't really had a weekend as of now. Had 8 hours of continuous stuff yesterday, teaching or taking live sessions or stuff like that, or on YouTube. Today already started. Can we take some doubts? Yes, we will do that. I'm in Bangalore right now. Should we all solve CSS problem excluding DP? Should we solve all CSS problems excluding DP? Why excluding DP? I mean, if we're gonna do that in this session, right? So I kind of went through all the problems quickly one by one, just to get an idea. Okay. Till this much we will be able to solve. Just before we start, I'm gonna quickly give you the disclaimer of what these last problems are. Why are you in Bangalore? Google offer work from home. Just to have fun with my friends over here. So this is like a smaller sub problem, and this has less number of people. So this is actually a problem which requires bitmask GP. So I think I have already mentioned a resource for bitmask GP which I had created, and you can access directly in the demo part of the training. So you guys can see that, and you should be able to solve problems like this or any problem of bitmask GP very easily after watching that. Okay. Then there is this one problem which is like there are like 8x1000 kind of thing is over here, and this is also you can solve it with bitmask, and a general version of this can be solved with matrix exponentiation. So you can also try this up, but we will not take these two problems today. Okay. And this is also a digit DP problem. We will not take it today, but what I have decided is I will like cover digit DP post maybe this session. Maybe tomorrow I will upload a video on digit DP, which is going to make it very simple for you guys. Okay, if you have seen the workshop. But the rest of the problems over here, except the last 3 problems, we're going to solve all the problems they are almost in an increasingly difficult order. So we should be able to complete all of them using the concepts that we have learned in the workshop. Even without that, you can also understand what we are talking about if you just know what DP is. Okay. Okay. Okay, great to see. Cool. Let's get started with the problems then. Can I have a quick plus from the chat if we can start with the problems? Everybody's ready to discuss problems, to solve questions specifically. So let's go through the problems one by one real quick, and we should be able to solve them pretty neatly. Okay. So let's start with the first problem. The problem is you need to. So this is the dice combination, right? Yeah. So you need to start with we will start with the first problem. So the first problem is your task is to count the number of ways to construct a sum n by throwing a dice n or more number of times. Okay. N or more number of times. So each throw produces an outcome between 1 to 6, and you need to make a particular sum. So essentially it's like you will do throws multiple number of times, and in each time you're going to get a number between 1 to 6. Finally you have to make the number sum n, find the number of ways to do that modulo a certain number. This is what is asked. Okay. So which form does this look like? Tell me the form. Just give me quick 1 sec to kind of set up this thing once. Give me like quick. So which form this lies in? Just like coin change, till we get the sum values 1, 2, 3, 4 up to 6. No, this is not exactly the same. Think about it. It's not form 1 actually. Think about it very like, I mean, you can solve it with form 1 too. Okay, you can solve it with form 1 as well. It's not really that difficult. But 1 comma sum, no, not really. What exactly are we using over here? Why I comma sum? What is I over here? What are we iterating on? What are we iterating on in this one? 1 sec. Iterate through till 6, right? With 6 transitions. Yeah, that is also a better way, right? So the way we will model this particular problem, that we have to construct this using like coin like dice throws 1 to 6 is using form 2. Why do we want to do it with form 2? Because in this case you don't really have this setup, right? That there are like a finite number of steps, and then in each step you have to decide 1 to 6. We can do any number of steps, right? So it's not a finite construct where we will write like when I is equal to n, we will be at a base case and things like that. So it's not a form 1 directly. So instead it's wise to kind of keep it in form 2, because it's like a sequence of like dice throws, right? And like there will be first dice throw, second dice throw, and eventually you want to reach the position, let's say a sum, right? So let's say you want to reach this particular sum. Okay, how could you reach this particular sum using a last dice throw? So what could be the potential values of the last dice throw if you reach this sum? Maybe you have got a 1, so you would be at sum minus 1 and you got a 1 and then you reach this. Or maybe you were at sum minus 2 and you got a 2 and then you reach this, right? Or you got a 3 and then you were at sum minus 3 and you reach this, right? So, or maybe like up till 6 you were at sum minus 6 and then you reached this, right? So that is the last thing that could have happened, right? in the last dice throw that you made, we are getting either 1, 2, 3, 6, up till 6, right? One of these 6 numbers. Is this clear to everyone? That the last dice throw could have been any of these 6 numbers. Yeah, we will be writing iterative codes directly today. That is correct. Because in CSES, the constraints are going to make things till 10 to the power 8, and recursive codes are difficult to write in that case. I will give you the logic why we are going to, like, I'm going to write the same things directly, but like the iterative code directly, but I'm going to give you the logic directly, that why is the loop going this way and things like that. Okay, so in that sense, you would be able to follow things clearly as well. Okay, unique combination without any permutation. So it's like 1 plus 2 is different from 2 plus 1. So is this the last lecture? Tentatively yes, this is the last lecture for the DP workshop. Okay, this is just us testing whether we have actually learned skills enough to solve the problem. So this is form 2. Okay, form 2, and the state would be DP of what is the current sum. Okay, and like this is the ending state. We want to reach the sum, this much sum. So we can come from these different sums over here and with a one particular move. So the number of ways, the question that we are asked to things like this way over here is find number of ways. So we might like start with 0, come to this and then take this one, or come to this and then take a 2. So all of these will get added, right? The number of ways will get added. So it is nothing but dp of sum is going to be equal to the summation of sum minus I, where I ranges in the range 1 to 6, right? So the transition is going to be equal to dp of sum is equal to okay. Please try to give pseudocode of recursive code. I mean, recursive code, these things you should be able to write very, very easily if you have seen the workshop codes already. Okay, this is fairly simple. Then please start greedy next. Next we will see next. Okay, first let's complete things up and then we will discuss what to do next. Okay, 6 options, right? Okay, CSES gives TLE even on that case. Okay, so if this is the transition, then we can like kind of check the time complexity. It's like we know the time. How do we check time complexity? It is always going to be equal to number of states into 1 plus number of transitions. Number of transitions is 6, number of states is sum, which can go up till n. So in that case we can solve this directly using like O of n solution, right? So over here you are given an n, you have to take a modulo. I think in this problem it should not be a problem with taking a modulo. So integer n, c in n, right? We can write this way, that we need to calculate the dp till, let's say, something like this, 10 to the power 6, right? We can take up to 10 to the power 6, let's say. So integer dp, we need to fill a dp array, which is over here, and we can say that the number. So now we will need to write the code for like solving this. So from a particular sum, it depends upon sum minus 1, sum minus 2, sum minus 3. So what should be the loop? Yeah, we'll do multiple things, don't worry. Like there will be no like direct workshop as such immediately after this, after some time maybe, but for now we will do multiple different things. 0 to n, right? For 1 to 6. So that is the for transition. We will do first for the states, right? The states needs to be get looped. So what will we use for that? For loop, right? For integer I equal to, let's say, 0, you need to make 0, you need to make, let's say, n, I plus plus, you need to find out answers till this much. What is the number of ways to create zero sum? Tell me this. This is the base case, or else it's the recursive case. So if it is base case, the number of ways to make zero sum, like by default in such cases in counting problems, the default value that we return for such problems is 1. So dp of I is going to be equal to 1 for base cases, or else we're going to get into a transition. So for integer j equal to 1, j is less than 6, less than equal to 6, j plus plus, this is the how much did you made in the last move. dp of I is equal to 0, sorry, this is going to be over here, dp of I is going to be equal to 0, dp of I plus equals to dp of I minus j. Okay, provided that this exists. If j is less than equal to I. Okay, provided that this exists, we are going to sum it up in the dp of I. And we're going to get the value over here. We need to make sure that we take a modulo correctly. So mod equal to, I'm going to write over here constant int mod equal to 1e9 plus 7. And make sure that things are like done correctly, like integer might overflow over here, and you need to keep things in long. So data type I will leave for you guys to kind of resolve. Okay, but this should be enough for solving this problem. I mean, since you are solving this, maybe you can also do this way, that hash define. Sometimes when I'm like kind of bored, I just define int to be long and make this signed, because int long main doesn't really compile, but signed main or int main does compile. So if you just do this like this one line, every int get replaced with a long. Okay, or ideally you should make a LLI variable. That is the correct way, but sometimes I become lazy. Okay, so this is the full code for maybe like this one. We can test, maybe doesn't really make sense. Oh, we didn't print anything. So like you have to print the out dp of n. That's what we need to do in this case. Okay, that's what we need to do in this particular case. Is this clear to everyone? How are we solving this problem? Doesn't really make much sense to kind of run this. Is everybody clear? Form 2, how what is the number of ways in which we can make this sum? And the last move, that like form 2 by nature has its last move that was there, so we go through the last dice roll, what did that come up with, and find out before that how many ways were there to reach that particular state, and all of those things are getting added over here. So that's how we solve this problem. Clear everyone? Quick +1 if this is clear. We can move to the next problem then. So I need a quick +1 from everyone so that we are good to, like, I can understand that how many people are actually understanding stuff. I know for some of you maybe this is very easy, some of you this might be hard as well, very hard as well, but understand that like with the forms that we have learned, I think we should be able to understand all these things. Okay, only 4 + 1s, 4 5 + 1s. That's very weird. Rest people, you are not able to understand this, or this is too easy to write a +1. That can be the case as well. That can be a case as well. Okay, cool. Next is we want to solve this problem that consider a money system consists of n coins. Each coin has a positive integer value. Your task is to produce a sum of x using available coins in such a way that the number of coins used is minimal. Okay, that makes sense. So we are given n different number of coins and the desired sum of money, and we have to use like minimal number of coins as much as possible. Okay, so this is something we have to solve with dp. Okay, form 2, you can use form 2 for this one as well. Yeah, you can use form 2 again for this problem. Can you tell why Indian currency and Fibonacci series work 3D? So for each set you have to prove separately. For each different coin set, the proof exists differently. Okay, it's a greedy proof. dp of sum, minimum coins required to form that sum. Exactly, it can be done with form 1, it can be done with form 2, both of them. Okay, I not say it cannot be done with form 1, but we will prefer form 2 because this is very similar to the last problem, right? We have to, so if you remember, this is, both of these problems are very similar to the first problem that we had taken in the workshop, which was climbing stairs. We are at 0, we have to get to level n, and there are certain number of jumps that is given to you. How many, so this one is asking you how many minimum number of jumps is required, and the previous problem was asking you what was the total number of ways to reach the step n. Did you guys understand what I just said? The previous problem and this problem are both exactly same to the climbing stairs problem that we had discussed. Okay, that you are at stage 0, you have to get to the sum whatever is over here, and from this step you can take one. In the previous problem it was given that you can take 1 2 3 4 5 6. Okay, and what is the number of ways to reach this sum? That was what was asked. Okay, in this particular problem it is said that you can jump to certain numbers, like you are given certain like sets of numbers which you can take, maybe sum this over here, find the minimum number of steps in which you can reach the final step. Okay, that's what is being asked over here. So these are like an example of form 2 problems. Okay, and or you can do it with form 1. They are very closely related though. Okay, so very simply we're gonna use, I'm not even going to code this one, very similar to the last problem. dp of like sum, what is the meaning? So this will mean, so this is the form 2. So the meaning of this is going to be, the second step would be to find out the states. So state would be dp of sum, that is going to return minimum coins to make, okay, this sum. Okay, that's what is going to mean. And obviously this sum would be made by using some last coin, right? One of the coins would be used as the last coin. So we will simply use, again, dp of sum is going to be equal to, the transition is going to be min across all different x belonging to the set as given to us, right? dp of sum minus x, and the last coin you took was the value x which belongs to the set given to us, so plus one more coin needed. Okay, yeah, that's correct, Shivan. Is this clear to everyone? This one coin, this plus one, is coming from, you are taking this coin plus whatever is the optimal way to make this much sum using the coins that are given to us. So this is the full transition for this particular problem. Clear? Is the transition clear to everyone? Yeah, that is correct. 14, greedy doesn't really work. Okay, September. Okay, so Slack link, I think that you will get by tonight, and the first session should be on tomorrow. So okay, I'll say, if you guys are like joining in for the 4 September batch, it is from tomorrow. Why stream chat isn't visible? It should be visible, right? Just let me go back. Is it not visible? Okay, so some of them gets loaded, some of them don't. Let me check once. Why is it not getting loaded? Anyways, you guys can see on YouTube, no? Sometimes it loads, sometimes it doesn't. I don't know why. I mean, you're saying in the video, right? But you can see on the YouTube, right? Okay, good. So this is the same transition. Tell me the time complexity of this. What is the time complexity? Check the like input constraints and tell me the time complexity of this code real quick. Let's see if you guys have learned the formula. Very simple. N number of, like, this set contains n elements and the sum you have to make is x. So what is the time complexity of this thing? And each ci is up to 10 to the power 6. So what is the time complexity for this particular formula? For this one, O of n into n, no, that is not correct. O of n into x makes sense. Yeah, so the time complexity for this would be number of states is going to be equal to this sum. Sum can take up till x value, so x number of transitions is going to be the size of set S, which is n. So we have the formula x into 1 plus n, which is order nx. Okay, that's the total time complexity of this one. Is this clear to everyone? How is the time complexity coming to n into x? Quick plus one if things are clear up till this. I don't know what the inputs are, but something like this would be there. The code would be something like this. You need zeros. You need zero number of moves to make a zero sum, and then to reach a particular thing, let's say it takes infinite moves, and we don't need mod for this problem. And then you can take any one of the like n different options that you have, and if the jth coin is less than equal to the current sum that we can make, maybe the last move was the jth coin. So this is the full code. This is in fact the full code, but this is bx. Yeah, coming to this. Yeah, so this is the input part, n, x, and the ci values for each different sum. So since sum depends upon smaller things, okay, we go through in increasing order. By default, to create sum 0 you need 0 coins, and for any particular thing we keep initialize it with infinity and then like update it with 1 plus here. This is the transition part. Time complexity, we have this magical formula, right? number of states into 1 plus average number of transition for most problems, and this turns out to be x in this problem, and this turns out to be this turns out to be n, this turns out to be x. So it's an xn order xn complexity. Okay, so this is something I've covered in the bootcamp multiple number of times now. Okay, so this is something which we are done with. So somebody is asking that we can solve most of problems with both form 1 and form 2, so it sometimes confuses me, right? Try to use, like when you have to cache things across test cases, number one, or when you have to, let's say, when you have a natural sense of subsequence in the problem, okay, try to use form 2, or else you can use any one of them. Form 1 is definitely replaceable with form 2. All form 2s are not replaceable with form 1. Okay, there are certain reasons for that, but like I will leave for you to like use both of them in case interchangeably, because if as long as you are able to solve the problem, it should be good. You can think it in any one of them. Okay, but naturally it makes more sense to kind of use it for subsequence, or where there are like sequence of paths or sequence of moves that lead to something, right? In this case, right, when you have to generate subsets and all, that is where form 1 come into more like correct thing, or where you have to generate a string or things like that, digit by digit from start to end. Those are the cases when you use form 1. Okay, so that's the case of form 2. This problem clear to everyone? Just the simple change in the code should do the trick to kind of solve the problem. Quick plus one, and this is clear. Clear to everyone? Yes or no? No. So there are problems, let's say, like finding the number of distinct substrings, subsequences. That is something you can not do with form 1. Try to do with form 1, it will be difficult, but you can do it with form 2. Okay, so there are multiple different problems, harder problems maybe, where things would get relevant with having segregated forms. Okay, let's go back to the website. Let's see more problems then. So this is also now solved. Very simple form 2 problem. Okay, this one is very nice. This is coin combination 1. Each coin has a positive integer value. Your task is to calculate number of distinct ways you can produce a sum x using the available coins. Okay, and I'm gonna quickly, so this is like given a sum, you have to find out the number of ways in which you can kind of generate a given sum with each of like for a particular sequence you can permute the thing. Coin combination 2 is nothing but you have to consider each permutation only once. Okay, so the number of ways you can write some sums of the elements by repeating even as well, possibly, if you can make a particular sum, and you need to also count the number of permutations that kind of does that. So all permutations are allowed. In this case, only like every permutation gets counted only once. So it's like the collection is getting counted only once. Okay, that's what we do over here. So for coin combination 1, this is exactly same as the last problem, right? So the difference between the two is 225 and 252 are counted in the first one. That is not counted in the second one. That's the difference. Okay. Yeah. So this particular problem that we are seeing right now is exactly the same problem as the last one. I mean, if I go back to the code, okay, if I go back to the code, and instead of this, I just again do the same thing. This is going to be equal to plus equals to this. Okay, plus equals to this. This is going to work. Obviously take mod and stuff. I'm going to explain why, don't worry. And this code will work. Why is this working? So what we need to do is, again, we need to create a particular sum. So whatever the expression is, there has to be a last plus with something, right? So we iterate on that, and we find out which one was used as the last plus. So it might be +2 or +3 or +5. So iterate on that. Whichever one comes up, just subtract that and then find the number of ways to generate the other part using the summations. Okay, so that's what we are doing over here. It's exactly same as the last problem. It's just that now we have to count the number of paths. In the last problem, we have to find the minimum length of the path. Is this clear to everyone? Why is this similar to the last problem, and how did we like convert the code into this one? Click +1 if this makes sense. So what was the last number so this is form 2 again. What is the last number we took? We iterate on that, subtract it from the whole expression, and then find out the number of ways to represent the rest of the expression. That's all. Okay. So this is the current version, but in this case it's a bit different. It's a bit different. We cannot really permute the things, and this is where things become a bit more difficult. Okay. So the way to solve such problems is by generating the sets in a sorted order. So see, 2, 2, then 5, 3, 3, 3, or 2, 2, 2, 5, 3, right? So if we first decide on how many 2s do we need, then decide on how many 3s do we need, and then decide on how many 5s do we need. If we do that way, then we are good to go. So the first question is about permuting, the second question is about counting the number of 2s, number of 3s, and number of 5s. If we decide the count, then there is only one way to set it. It's the sorted order, like number of 2s, and number of 3s, and number of 5s. Okay. So if that is the case, how do we generate a sorted sequence that sums up to a given number? Now this is the problem. Find out this so whenever you have to find out distinct stuff, right? Number of distinct ordered, whenever this term comes up, distinct ordered ways, it's generally always using a sorted sequence of the numbers that are like as an option. Okay. So this is something I've already solved in the videos in day 4, specifically the coin changing problem. I have already made the video for this one. You can see on the channel. I can just quickly show you guys where that is, that you can refer to it. There is a very neat way to kind of understand this particular setup. Let me send you the problem link itself. So there is this, day 5 part 2 problem, which is coin change infinite supply. Each element has an infinite supply, and you have to find out the ordered ways to kind of generate a particular thing. Okay, this is the problem. Okay, so this is an ordered way to generate a particular thing. So what we do is, we first write over here, just to give you a summary, we write dp of, so we have 2, 3, 5. So we iterate over these numbers one by one. So now we keep dp of level. Okay, let's say we have dp of level, comma, a certain number sum that we have to make. Okay, and we are looping through the numbers 2, 3, 5, 7, whatever the numbers are given, and let's say we are currently at 5. So maybe one way that we can do is we can take a 5 in the summation. Okay, so in that case we're gonna go to dp of level, comma, sum minus 5. Sum minus 5, because we are at 5 right now. Or maybe we can go to dp of level plus 1. So what is this saying? This is saying that stay at the same level. So next time also I can take another 5, or stay at same level and take a 5, or move to the next level and don't take any more 5s. This is what the transition looks like when you have infinite supply and you want to generate an ordered set. Okay. So is this clear to everyone? Why we are like keeping a level over here and not going to level plus 1? This is something I've covered in that video as well, that if you put a level over here, it is like it works like an infinite supply. If you had made this level plus 1, it would have worked like a single supply of every element. Okay. Clear everyone? This is level plus 1. If this is level plus 1, then it's a single supply. If it remains level after the transition, it is infinite supply. So you let the element to be taken again. This can again go into dp of, let's say, level, comma, sum minus 10. Okay, and so on. Yeah, we could take any number of coins, but the formulation was different. Now we are writing it in form 1. Okay, and we are deciding for each number how many times we are taking, and let's say we take 2 times, 3 1 times, 5 3 times. Okay, so the only way to represent this is nothing but 2 plus 2 plus 3 plus 5 plus 5 plus 5. We need to keep it sorted. In the previous problem, it was more about you can take any one of them, and then like the order also matters. So in that case, we decide what was the last number that was taken. So we model that in form 2. What was the last thing that was taken? What was the last thing that was taken? And accordingly, like kind of add the number. So that is the difference between the two problems. So modeling the previous problem with this kind of an idea is difficult because we have to count the permutations. So we loop over how, like, what was the last thing being taken, which all of the three are equally likely. If there are k supplies, then we have to loop through it, but there are some ways in which you can optimize it. It's a harder problem, but there are actually some ways in which you can optimize that too. Okay. Like 0 to k supplies can be optimized with certain prefix sums, but it's a harder DP problem. Okay. Let's move on now. For this one, we are done. Okay. Next is removing digits from a given number. On each step, you might subtract one of the digits from the number. How many steps are required to make the number equal to 0? Is this very straightforward? Which form does this one map to? Form 2, right? Is this clear? This is just form 2 problem. Why is it this form 2? Because there is a sequence of moves involved, right? Path, sequence of moves is always form 2, okay? So on step, you subtract one of the digits and get the number. So we will mean this way. Form 2, dp of a particular number is the, what is the question asked? Minimum number of steps, I guess, right? What is the minimum number of steps in which you can get? Yeah, minimum number of steps. So minimum number of steps from number till 0. So this is number of steps starting from number to 0. So we said that form 2 was also ending and starting, right? It is equally possible that you keep it at starting, because we have to keep it starting because the transition depends upon the current number and not the next thing that is going there. Okay. Interestingly, greedy works here. Okay, that's correct. But we are not getting into DP and proving stuff today. So for this particular DP, we have this number. What we can do is we can find out the digits of this. No, we cannot get into proofs of such thing. For this one, we will go through the number and we will find out its digit. So from DP of number, we can do for each D belonging to digits of the number that we have currently, min across, we can subtract that number. So num minus D plus 1. This is what we keep over here. Okay, this is what we keep over here across all the digits that are there in the number. Go through them and try to delete that particular digit and see if that is, like, if you delete that digit, then you're making one move plus whatever is the next moves required from this number to get to 0 is what you do, what you need to do next. Okay, so this is what we can solve with. Is this clear, everyone? How are we modeling it with form 2 and what is the transition? Is the state and transition clear to everyone and the form clear to everyone? Quick plus 1 if this makes sense. This is easy. Should we take number as string here? You can do both the ways. You can do both the ways. But I will do it just with, let's say, numbers itself. Okay. Wait. Okay. So let's go over to the coding part. Let's code this up real quick. It should be very straightforward. How do we do this? I don't want to remove most of my stuff. So let's remove this much. Okay. So we are given x, right? And what we can do is we can kind of get, like, let's say, what are the different digits? We will find out integer over here. Get digits of a number x, and what we will do is set int digit while x digit dot insert x mod 10. So take the last unit place digit and insert it inside the set, and then remove that from the number. While the number exists, we will go through all the digits. Yeah, the digits, that is actually correct. The transition or the digit to try depends upon the current state. That is absolutely correct. So the transition might not be like across all the states same, right? It might not be that way. It depends upon the current state. So this is there, and then we return the digit. Okay, so what we do is we go from for integer. So for a particular number, if we subtract a digit, we are always going to get to a smaller number. So it is okay if we loop through 1, sorry, from 0 till the number x that we have to form, or in this case there is only one number given to us, right? Yeah, so it doesn't really make any more sense with keeping x and stuff. We can do it this way. Okay, from this one, if I is equal to 0, that is the base case, because we have to reach 0. So how do you understand base cases? Very simply, if some answer is trivial, write it in the base case. If it's very trivial, okay, but don't overdo that. Okay, but if something is very trivial, you can write that in base case. Somewhere the code has to stop, right? I is equal to 0. There is 0 steps required for this. Or else what we will do is we will get the digits of a particular number for auto d in the get digits of a particular number of the state that we are currently in, the number that we are currently in. Okay, dp of I, we are going to take maybe infinite number of moves. So since we have to find minimum, we will set it with an infinite value, which is like 1e9. We will never need 1e9 number of moves, and across all the digits that are there in the current number, okay, maybe we can try and do, what we can try and do is dp of I is equal to minimum of whatever moves we are currently required, or maybe if you take this digit subtracted off, you subtract it from the number, so you get I minus d. So whatever is the number of moves required from over here plus this one move of removing this d is this much, make a minimum at this dp of I, and that should be one of the possibilities. Very simply, this is the whole code. This should be dp of n. That's all there is to the code. Okay, since the number of digits will be very small, 6, set doesn't really add much of our complexity to our complexity, but if there are multiple digits, we will only count them once, so that will optimize the transitions a bit over here. Nothing much optimization over here, but still, on the worst case there can be 6 digits, so we might have 6 transitions over here, and each state is up till n. That should be fairly small for this problem. Okay, so you can go back and see it's up to 20^6 with 10 transitions maybe at most every place. Okay, how can you check if dp works for greedy? A very simple rule. Maybe write a function which finds things greedily and check if the value is coming out same for the smaller values. So maybe you will write a brute force kind of code, maybe you will write some other code, maybe like integer get answer for a number x. Okay, and you write some greedy strategy over here, some greedy strategy will give you the answer over here, and then check, like assert, let's say dp of I is equal to get answer of I. So if this is getting correct for a lot of small values, then most probably it's going to be correct for a bigger value as well. So this is how you can check. Okay, or else you have to prove it on a notebook. Ideally this is what I do. I go on intuitions and then prove, and then just check it with some smaller values. If that is correct, most probably the intuition is correct, so it's okay to code it for a bigger number and submit it. Anyways, you will not have to code it because you already have the logic written over here, right? And proof by theory is by swiping and stuff, so we cannot do that now. We don't want to get into proofs. Okay, because I don't want to get into greedy, I've not shown you guys how to prove stuff in greedy already, so I don't think I'll be able to, in the given time frame, explain to you guys how to prove stuff. Okay, there are 2-3 strategies that are used to prove greedy stuff. So this is there for this one. Okay, exchange argument is one of them. There are many such things. Okay, let's go forward then. Okay, so this is how we do. Very simply, what is the current digit being removed and transition based on that. Okay, I will list it and add it to the comments maybe in future. Okay, I don't have them like right back in the mind right now. Okay, removing digits done. So how many problems have we done already? Let's see. 1, 2, 3, 4, 5. 5 problems done. Nice. Many more to go, guys. Let's see. So what is the problem right now? We are given n cross n grid whose squares may have traps. It is not allowed to move to a square with a trap. Your task is to calculate the number of paths from upper left corner to the lower right square so that you can move down or right. Is this everybody can solve this one? I have already solved this, but yeah, this is very simply form 2. Like I think we have solved this multiple number of times already. I mean, I'm gonna just write the code. So I'm gonna show you a very neat way to write this. I have already shown this in the like workshop, but back then we were learning iterative, so we were doing recursive code. So I will show you guys maybe one like simple idea to maybe solve such problems, or the way to write the code so that you can do that very neatly next time. Okay. So we have to find the number of ways to reach, let's say, some I comma j from 1 comma 1. That's what we will keep, or 0 comma 0. So the input is a string, right? I guess, yeah, it's a string. There is no space in between. There is no space, right? So what we can do is we can try and take a vector of string. Maybe this is what I do generally. Just see the coding. I just want to show you guys this. N scene n comma. So it's going to be n. It is n cross n. So arr dot resize n. For up till n size, scene arr of I. This is going to take the whole map, which is dot and dash, dot and hash. Okay. Then what we do is integer dp. So dp is there by default. Okay. I'm going to assume that like for integer I is equal to 0, I is less than n, I plus plus. For integer j is equal to 0, j. So since a particular cell depends upon I minus 1 comma j and I comma j minus 1, like the number of ways to reach this cell is through this cell and this cell. So maybe we can loop this way so that we have computed both of these things by the time we reach this. Okay, this is nothing but I minus 1 comma j, this is nothing but I comma j minus 1. So we have, out of these two, we will count the number of ways, whatever that is. So over here, this is j is less than n, j plus plus, right? So what we'll do is, if I is equal to 0 and j equal to 0, that's the base case, or else we will compute things. Okay, in this case dp of I comma j is equal to 0, sorry, is equal to 1, and then we will compute the value if it is not the case. So if I dp of I comma j plus equals to dp of I minus 1 comma j, if j dp of I comma j plus equals to dp of I comma j minus 1. So what I just did was, if the previous row exists, if the I is like non-zero, then only we go to this transition, or else we do this transition, or else by default, like, obviously we have to keep this as 0 by default. Okay, so these are the two different ways. But one very last thing that you have to do is, in case whatever you computed, in case if arr of I comma j is equal to hash, okay, in that case dp of I comma j, we overwrite it with 0, no matter what computation we have done by now. If this is hash, it will become 0, so that anytime next time you kind of add this to something else, it will add 0, because this was hash. You cannot come here and go to some other place, right? So this is what we can do over here, and simply return cout dp of n minus 1 comma n minus 1 should be enough to kind of solve the problem. This is all the code that is required for this problem. The code looks neat. Is this coding style clear to everyone? How did we code this particular thing? We have written the same thing, but it's just written in a bit neater way. Maybe, like, I don't know if you could do it in much simpler ways as well, but this is what you can. So two things to pick up. One is these two syntaxes that I wrote over here. Decide transition based on this way. Okay, so that you don't have to write too many if else. And over here, this one, that let it compute and override the value with a 0 in case it's a hash or it's a blocked cell. So that's why we should do it this way. Okay, clear with the coding style? quick +1 if this is clear to everyone. And I expect everybody to put in a +1. Please do put in a +1 if you have not yet put in a +1 ever in the stream yet, and you're still watching this one. Why are you not clear on this one? I expect at least 10 +1s because at least 30 people are watching. Yeah. So this lines remove default handlings for the first row. It makes it like very easy for the for the first rows and the first column to be handled. So Ram is saying like stream. I know like that's the words get stuck in mind, right? Like the stream if you have not done it, guys. That's a good reminder, Ram. Supporting the stream makes you a moderator. Chalo, next. Let's move to the next thing. 0 false, anything greater than 0 true. Yeah, I mean if that is possible to go there or not, that is true. Yeah. Next question. What is the next question? In a bookshop which sells n different books, you know the price and number of pages for each book. You have decided the total price of your purchase will be at most X. What is the maximum number of pages you can buy? You can buy each book only once. Which problem is this problem? It is a famous problem just written in a disguise. Which famous problem is this? And voila, it's the knapsack problem, right? In the knapsack you have a bigger weight. This is X. And total price, so each item you know the price, so the prices are the weights and the number of pages are the value of the knapsack that we had, right? And each item can be taken only once, so it's a 0-1 knapsack that you can take it either 0 times or 1 time. So this is something we have already solved before. Very simple, very simple. Okay, we will do this in form 1. Okay, dp of, okay, or I should write it right now in this way, level comma a particular sum that what is the maximum value that you can get using this much weight or this much price. Okay, this much price left, this much budget left. It's a budget, that's the budget, right? In the question it's the budget that is given, right? Just to confirm, purchases will be X. Yeah, so you are given this much budget, so what is the budget? Okay. So from this level you can, so this is the level and this is like you have these items, how much is the maximum pages you can read out of these items. So over here, like very simply, dp of level comma budget is given. Maybe you can try and take or not take. This is direct form 1. This is very simple. We have discussed something similar as well. So in this case, dp of, you will go to level +1 because if you take it you cannot take it anymore, so level +1, and you will limit your budget with the b of the level, whatever the price of the level was. Okay, plus, but since you took this item, you're gonna read the number of pages that was there in the level item, right? If you don't take it, you're gonna go to dp of level +1. You will have the same budget left, but you will not get any more pages read for that item. So this is how you model this. Time complexity wise, the level would be very simply, this would be nothing but 10 to the power, level in this case is given to be 1000, or sorry, this is given as, what is the input, what is the variable used in the problem? The input given is n and x, so that is the budget and this is the maximum budget and this is the number of items. So this is nothing but n, this is nothing but budget, or which is nothing but given as x. So number of states is going to be equal to n into x. Number of states, number of transitions in this case is 2, so the formula will finally get you order n into x. What is the formula? Number of states into 1 plus number of transitions. Okay, that's the formula, and you will get n into x as the final complexity, which is fair enough. Like 10 to the power 8 will pass in this case if you're writing iteratively. Okay, do we need to write the code for this one? I think I have already coded this one in the streams before, so you can check the day 5 videos. I have already coded something similar in the streams. Okay, so we can skip this particular problem's coding at least, because it's a very simple snapshot problem. You will get plenty of implementations, maybe even optimized implementations are possible. You can read more about that, but yeah, you can get more and more ideas for this one, so I don't think I need to cover this one specifically. Okay, let's go to the next one. Okay, what is this? Did you came to the same problem? Yeah, this one. You know that array has an integer n between 1 to m. The absolute difference between two adjacent values is at most 1. Given a description of the array where some values are unknown, your task is to count the number of arrays that match the description. It's a very good problem. Okay, which form does this lie in? Which form this problem lies in? Tell me this. Each element has an option between 1 to m, and you have to check the absolute difference between the two adjacent values is at most 1. Which form this problem lies in? I will give you guys some time to think about this one. Personally, I would prefer this to be a form 1 problem. Okay, is there any prerequisite to solving CSES? Yeah, knowing about DP is prerequisite. We have already covered that in the workshop, so that's why this is all easy now to certain sense. So that's why, if you have not seen the workshop videos, then following the forms and stuff would be difficult, but the DP transitions would be easy to understand. But yeah, in this case we have certain options for each place. So it's in this case we have some options over here. So to iterate through options, it's form 1 only, but there is this new kind of a setup, right, where some values are already fixed. Okay, no problem. So we'll try to code this one for sure. So this is going to be a form 1 problem. So you're given, so what we will do is we will go through these elements and we will try to decide what is the element that we will place over here. Okay, so to make sure that this element is correct, we need to this interaction is correct. So what is given? Adjacent elements should differ by at most 1. So it's restriction on neighboring interactions, right? Neighboring interactions. So you have to keep track of the last element to make sure that this element checks with the last element, and then when we will place this one, we will check this interaction over here. Okay, so we will only check the last interaction over here for this element. So we'll keep DP of which level we are currently placing and what was the last element we placed over here in the last position. Okay, this is what we will keep track of. And over here there are two options. Okay, if this was by default 0, okay, if this was 0 case, then you have multiple options over here. You can place 1, 2, 3, 4, so on up till m. Okay, out of these two, the only thing that makes sense is to be using something that is 1 plus then 1 or minus 1 plus then the last one. So out of these you can only use those which are at most 1 distant, less than equal to 1 distance from last, and in that case it should be a feasible thing. In case this is a fixed value, this is an x, some fixed value, so you have to make sure that x works with this last and then move to directly DP of, let's say, level plus 1 with last being x. This is what we can do over here. So what we did, we kept track of what was the last element. We will, if this is 0 right now, then we will try to go through all different choices that we have, try to place 1, see if it's working, 2, see it's working, 3 if it's working, and so on. Okay, other thing that we can try and do is, if it is a fixed number, it is by default 3, so the first and the last over right now was 5, so this is not valid. So if it is 3, then you cannot change it, right? So it is already void, you will return 0. It's a pruning case. Okay, or else if this is, let's say, non 3, or if it's, let's say, 4, then this interaction is fine. So we will put a 4 over there. We will pretend that we just placed a 4 over there, even though 4 was fixed. We will pretend we placed 4 and we will just move forward. Okay, so it's in rest of the places where there are 0 element, we have options from 1 to m. In the places where there is a predefined number, we have an option of 3 to 3. So that's how we will pretend that the options are there for each element, and we will move through in the transition that way. So that's the transition at each position. For the elements of 0, we have whole room from 1 to m. For element that is fixed, we will pretend that we have only option 3 to 3, and we will solve the problem accordingly. Is this clear to everyone? How did we do this one? Let's try to write this very, very quickly. How do we solve this problem? So we will get an n array. I think this is the same as same input. just to show you guys to quickly code this one and maybe solve this. So we have 1000 and 100, m is up till 100. We can use form 2 for the same, right? Yes, we can do form 2 too, but I think form 1 is much more natural because you have, for every element you have some choices. That's it. You have when you have fixed length and you have for every element choices, it's form 1. When it's unfixed length or there is a sequence of moves that leads to something, it's form 2. That's the thing. Okay, that's a much better way to think about it. So we loop through all different ends. Okay, and in this case, like the level depends upon level plus 1, so we will loop backwards. Right, and integer yeah. I just got habituated with the monopile, so nothing, I cannot do anything more. I is equal to n, I is greater than equal to, so this is there. If so, we will write the base case over here. If I is equal to n, in that case everything we have placed, there was no problem in the interaction, so we will count that. So dp of I comma last is going to be equal to 1. Okay, else we will try to write the transitions if it's not the base case. We are at a particular position where the last element was something like this, so we'll check if ARR of I is equal to 0, or else there are two different ways. If it is 0, then we have options. So for integer j equal to, let's say, so we don't really need to like loop over all options. So one thing is that we can try and loop over all m options, but we know that the difference will be like just +1, -1 or 0. So we can loop over for integer difference is equal to -1, difference is less than equal to 1, difference plus plus, right? So the absolute difference should be up till 3. So if you know the last element and you know the difference, then the current element being placed is nothing but last plus the difference, right? This is the allowed difference for us. These are the three different allowed difference. This is the current element that we are trying to place. If we place with this, then we can go ahead with dp of I. So what is the question? We are counting or we are finding the minimum or something? We should be counting, right? By the number of arrays, right? We are finding the number of arrays. Hi Mukesh, 3 videos in DP hidden. So those were something we removed off later on. It's not part of the workshop. Like those were like other uploads which are not part. I don't know why they are hidden. I will check after this stream. I think somebody else also mentioned this. So dp of I, by default dp of I comma last is equal to 0. We don't have any move, any option. And in this case dp of I is going to be equal to dp of I minus I plus 1 comma the current element. That, so whatever you placed over here for the next state, it is the last element, so we push the current over there. Okay, and this is how you get the dp of I comma last over here for this state. Okay, and if it's a fixed number, then we don't really have an option. We have to place one more thing, small more thing over here. We need to make sure that this lies in the range 1 to m if current is less than equal to m and current is greater than equal to 1. Like in case this becomes less than 0 or stuff like that, right? I think m is also given to us, right? I comma last over here, yeah, that's correct. So over here in this case, we have to kind of go with the last element only. Sorry, no, the ARR of I element only. It's forced, okay? And if abs of current minus last is less than equal to 1, and yeah, so if this is the case, then we can use this current element and we will add this to the dp and it will calculate the dp accordingly. So I mean, just only one transition is there, so it is anyways going to assign it. Okay, so if it is 0, then we go through the three different options. If the last was some x plus 1, x minus 1, x. So these are the three options. We will go through them very neatly over here like this. Okay, and over here we're gonna go through only one option, which is current, which is the fixed element. and check if it is valid with the last element or not. Only if it's valid, then we will update with the value, or else it will remain 0. So this is how it will calculate the dp of I comma last. And at the end, you have to make sure that you need to find what was the, like, you start with 0 but you place something at the last, right? So maybe what we can do is we can place something like we can try and place something like 0 over here. No, I can do it this way. So for the first element, we can try and place everything integer answer. So we have solved something similar in the live stream also. For the first element, we will place something, or maybe we will do it this way. How do we do it the best way? We need to call dp of 1 comma something over here, which is like the last element which doesn't match with anything, or it allows us all the different transitions, right? Okay, line number 18. Yeah, n to 1, n to 0, that is correct, right? Because I depends upon I plus 1. So we are going through this. So we are also updating the base case, right? So it's fine if you use it. Okay. So for the first element, we will do the manual transition. This is where I feel sometimes like iterative codes are not that good, that you have to write more code. Okay. It's boring. Okay. So for the first option, today is the ICPC preliminary round. When is that? What is the time? So we will never hit this code, right? Error of n. Why is that a problem? We will allow everything for the first element. So last is actually equal to something like free. So for the first element, if error of 0 is equal to 0, we will allow every element from the range 1 to m. This is obviously going to be true because we are looping on that. And if it's fixed, then we just allow that fixed one and go with this. This is the thing. So for the first element, there is no restriction like with the last element. So this is how we compute it. Okay. That's the whole coding for this particular problem. So this is the form 1 part of it, and just to be able to find out the answer, what we do is so for the first element there is no last, right? So it doesn't really behave the similar way. So we loop over all the options for the first element. So if that is 0, then we have all options possible, not just 3 options. And in case it's a like non-zero element, then it's fixed. So we simulate on that. And after that, the number of ways that is there is given by dp array. So we can use that to get the answer that is there at the first element. So for the 0th one, we are calculating it a bit differently, and then from 1 onwards, we need to use this logic that is there. Okay, because for the first element there is no last, so there is no interaction with the last. So you have to do that transition manually over here, and this is why like sometimes I feel iterative codes are bad and recursive codes are superior, because they handle this very neatly. Because you can pass in some random parameter over there which will not behave, which can help you put exceptions to things. Okay, so that's almost the code for this one. Is this making some sense? Is the logic clear over here? Like how did we loop through these 3 things? Yeah, but no. So for the first element, we have to bind it to the second element. So the way we behave is that first element has a free choice, but the second element has to get binded by the first element. That's how this dp is handling it. Understand the constraint? We are binding every element to its previous element, So the binding from the first to second is handled at the second, not at the first. So first is free, second is restricted on first, and and the rest of the code will handle that very neatly. Okay, that's how it's working. Always, like if you have some element which depends on both the sides, shift always to the one side. Always shift it to one side. Yeah, iterative coding is difficult, I know that, but just because we are doing CSES with iterative coding, I just wanted to show you guys how to do it. Okay, this is how we can do this. Obviously mods and stuff would be required. Clear everyone? Quick plus one if this makes sense. We are almost moving towards, like now slowly towards harder problems. Is this clear? Quick plus one from folks who are in the chat. Plus, okay, that's pretty nice, Shashank. Everything is clear. I mean, but we have not even solved that many problems. Chalo, I guess then it makes sense. If you guys are able to understand this much of code, then you are already at a very good level. Okay, it's already 3:40. How many problems are we done with? Let's see. Let's go back and check. So we are done with array description. We are left with 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 problems more. So 1, 2, 3, 4, 5, 6, 7, 8. 8 more problems. 1 mod 0. What is that? A high undefined plus 1 mod 10. Great. Let's go and solve the next problem, which is counting towers. Okay, I will give you a quick 2 minutes of time to think about this particular problem. This is, I feel, one of the best problem that is there in the whole set. That you are given a tower of height n. You have infinite supply of blocks which are rectangular in its dimensions. How many ways can you model the tower in with the, like how many ways can you tile? Let's say there is an n cross 2 thing, you need to tile it with rectangles. How many ways are there? So these are 4 different possible solutions. So how many ways are there if you can solve it? I mean, how many ways can you solve this particular thing? That's what we need to solve this in. How do we solve such problems? Which form? How do we look at it? There are test cases too. Think about this problem. Okay, I'll give you quick 1 minute of time to think about this particular problem. Think about this particular problem for a quick 1 minute. And tell me which form do you think this is going to lie in? Okay, I'll be back in a quick 1 minute. Okay. Okay, let's see. How to become good at iterative? Most probably with practice itself it will come. But if you have gone through all the videos and if you go through all of the CSES problems writing them iteratively, you should be good at iterative DP by that time. And like paper cut, but the number of cuts is not fixed. We can kind of try and do that. Yeah, makes sense. But the number of transitions would be too high for that. I mean, there are too many options So the number of transitions itself would be very high if you do it that way. Okay, so this is one difficult problem, and we will try to model it with, yeah, there are also restrictions on vertical cuts. Okay, so we will try to find differentiation. No, we will not do that much. It's not difficult. Okay, we will do it very simply. The way we'll do that is we will use form 2 for this problem. Reason being that because there are test cases and you need to cache, maybe we'll try to cache across test cases. So we'll try to model this with form 2. How do we write form 2? So let's say there is an n length subsequence. Okay, let's say there is an n length sequence which we want to find the number of ways that you can create this way, such that it ends with a dash over here or a non-dash over here. So I'm not closing it at this particular point, but it's like this, or you can figure out what happens on this side. It's up to you. How many such n length sequence are there? Okay, like these are potential there, but I don't know what is there, but it is ending like this. Or how many n length sequence are there which are ending like there is not a middle ground over here, and this is how it looks. Okay, so how many n length sequences are there, how many n length tilings are possible, or how many ways you can model an n length tower such that the last one has an extended like this, and then we will close it to make a tower. But let's say it's not closed right now. This is how what we are modeling. The number of ways to create things like this is going to be dp of, let's say, n comma 1, and the number of ways to create things like this is going to be called as dp of n comma 0. Okay, is the meaning of dp of n comma 1 and 0 clear to everyone? What do we mean by these two terms? No, we cannot do it for a general case. It's very difficult. I mean, we can do it, but it's going to be difficult. So the dp of n comma 1 means the number of ways we can, maybe let's say what is dp of n comma 3 n 2 comma 1. So it's like 2 piece thing, such that you need to make sure that this has a dash over here. Okay, so one way is this. Other ways, like if you have a dash over here, you cannot have just this line, right? Because then it will be like a non-rectangular piece. So maybe it's like you don't have this line and you have this, or maybe you have this line and you have things like this, right? So these are some of the options that I have. If you have like a sequence ending at a dash over here, okay? Is this clear to everyone? That if you have a sequence which is not, I'm not saying that it is closed yet, okay? It's not closed. But if it is ending at a dash, these are some of the options that I can have over here. Because I cannot put just one line over here in such cases. So what I'm saying is dp of n comma 0 means that there is a 1, 2, 3, like something like this kind of a piece. Okay, 1, 2, 3. Where the third piece has no dash in between. There is no dash over here. Okay, no partition between the last element. In the last element there is no partition between the two. dp of n comma 1 means there is an n length sequence, but the last element has a partition between them. Okay, how many ways are there to create something like this? That is what we are trying to find out. This is the two different dp values that we will try to use. Okay. Is the meaning of dp clear for this problem? It's the toughest problem I already have said, so it's obviously going to be a bit non-trivial. Is this part clear? The meaning of dp? How do we merge then? Let's try to find out the merged value. Let's try to find out dp of n comma 0. So you have something over here with no dash over here. So one option could be, I could put a line over here and then no dash over here as well. So dp of n minus 1 comma no dash. Okay, I could keep no line over here and then no dash over here, and then still I need to find out with n minus 1. So maybe Again, there is a possibility of dp of n minus 1 comma no dash. Okay. Now let's say possibly I can also try and put a dash in the previous part. So over here, then in that case I can put a full line over here, which is dp of n minus 1 comma ending at a 1, which is ending at this. Okay, this is one possibility. What else can I do? Can I do anything else? I cannot have just one line over here. I cannot have just this ending. I cannot have just this ending. So all three has to be together, or both of these needs to be there. So this is the only three different transitions that is there for this particular part. Okay. How many ways are there to end with an empty part over here, like empty thing over here? So you can close it over here. You cannot close it over here. Okay. And then the other is you can close it, and then last one is also partitioned right now. So closed but not partitioned, closed but partitioned, and non-closed. So it will not also will not be partitioned. So it is 2 times n minus 1 into 0. So this is the three different things which will get added up. Okay. Let's try to find out for dp of n comma 1 over here. Okay. So over here, maybe what we can try and try to do is that the previous one is, let's say there is a no line over here. Okay. So in that case, this has to end over here. So we need to make sure that we'll add a line. So one option is dp of n minus 1 comma 0. Okay. One option is that. The other option is maybe, so if you don't have the line over here, then you have to close it over here for sure, right? There is no other options. Maybe another option is that you have a line in the next one. So we are talking about dp of n minus 1 comma 1s. Okay. So in that case, like there is a line over here and there is a line over here. In that case, we can try and keep something like this, which this one is continued and this one is broken, or this is continued and this is broken, or both are open, or both are closed. So there are 4 different options in this side. Okay, 4 different options in this side. So 4 into dp of n minus 1. So what we are trying to find out is that if you have to find out something which is ending like this, and if there is something which is ending like this. So what is the last thing that you do in the last case? That is what you are iterating on, either 0 or 1, and then find out the number of ways to things places over here so that it matches correctly. That's what we are trying to design transition on. And once you have these things made, then you are done with the whole problem, because the rest of the thing is just coding. So let's first code, and then I'm going to explain it once more, because this is I feel this is one of the most hardest problem of the set. So I assume that this is going to take at least 4 tries to kind of understand what is exactly going on with the transitions. You have to write it properly on a notebook yourself, and then you will get to understand, okay, this is what is happening over here. Okay, dp of, so for, okay, I don't have any n, right? For, let's say integer I equal to 1, I equal to 0, I is equal to 1, I is less than equal to 1000, something 6, I plus plus. Okay. So dp of, so if I is equal to 1, there is only one line. So dp of I comma 0, not closing a single set, a single column, is going to be just one way. dp of I comma 1, like not closing a partitioned one, is there is also a single way. So that's the 2 base cases that we have over here. Else we are going to use transitions. So dp of, we already wrote over here, dp of I minus I comma 0 is going to be equal to dp of I minus 1 comma 0 twice, I minus 1 comma 1 only once. Okay, dp of I comma 1 is going to be equal to, over here in this side, okay, it's going to be dp of I minus 1 comma 0 once plus 4 times dp of I minus 1 comma 1. Okay, that's the 2 things that we have, and from this we can understand that how we are getting the next 2 values, and you can try and see that the final answer is going to be cout dp of I comma 0 plus dp of I comma 1. Let's see if we have like kind of found out the transitions correctly just by running it on some sample. Okay, let's see if we have got the things correct or not. Let's quickly see with the example. What is the examples in the problem? Oh, there are test cases too, so no problem. We have actually cached it across the test cases. So if you think about it, like if we run it only once, right? If you run it only once, these are test cases. We're gonna run it for multiple different test cases, but what we'll do is we'll run the solve only once. So it will solve for all different DP values first, and then we will get an integer n, c in n, and we will see out DP of n comma 0. It can end at a closing thing or a open thing or a closing thing. So both of them will get added, the number of a's. Okay. Let's try to see if this works. Okay, some compilation error. Let's see what I made as a silly mistake. DP of I minus 1, and I have not used a variable I. Oh, this is not needed. We are printing at the bottom. So this is obviously exceeding the thing. 2864. What is that particular? Are we getting that correct? 2864. So this is also correct. And the other one is not correct because we have not used modulo in the whole expression. Integer modulo equal to 1e9 plus 7. Just do these things with modulo properly. Mod hash define int long. Now if you see, yeah, this also seems to be correct only. Yeah, 64040 something like that. The same thing is coming over here as well. Okay. 6404 something, whatever that is. Okay, this is coming correct. Now let's go back and try to understand. So this coding over here is like something which we have done for every different n. Since it's form 2, it can be cached across test cases because n is like a fixed number, right? Like for a particular n, the answer is always fixed. So you don't need to recompute the DP for every test case. You compute it only once. But over here, we are trying to find out it using form 2. Like, so how many towers end like form 2, but there are two different states which we keep. DP of n comma 0, which is how many of things end with non-line over here. Okay, so in that case, there are two different options. The previous thing contains a line and previous thing don't contains a line. So over here we can get into two different options. One is this doesn't contain line, this doesn't contain line, or this doesn't contain line but the previous one contains a line. So in that case, if this contains a line and this is not a line, we have to make sure that this is put over here. So there is only one way in which you can kind of last one have one option. But if both of them don't contain a line, it is possible that you can put this whole line or not, right? Either there is this or there is this. So there are 2 into DP of this. Clear? Yeah, that is correct. That is correct. Ends with, so in form 2, you always use what does it ends with. Okay, that's what we use in all those problems. This would be very hard for variable width. Yes, you will have to like write many cases. And for variable width, maybe you will have to compute it with some graph computation, maybe. I don't know. Maybe some bit mask could help. Okay. I don't expect everybody to be clear on this one, but like, did you guys get some sense on how we are trying to write the thing? Try to write the transition this way by seeing what happens to this one and the previous one. Is it this one is a gap and then the previous one has a line? Then what happens to the options over here? Like in this case, why did we had a 4 over here? because we had, for this one there is a line, for the next one there is a line. So now we can have just this much, or just this much, or all of these, or none of these. So both of them are feasible. So that is like the 4 different transitions over here. If the previous one is not there, then we have to close it. So there is only one transition. So that's how I'm writing the transitions. Try to understand this and write the transitions like the diagrams once in your notebook. You will be very, very clear on how this TP is being calculated. Okay? Clear on this one? Pick +1 if this makes sense. This is the most difficult problem of this whole set, in fact. Or second most, maybe. First most or second most, either of the two. This is the most hardest recurrence that you have to come up with. There is one more which has a very hard idea, but this is the most hardest recurrence that you will have to come up with in the whole set. In fact, I remember back when CSES was up for the first time, even like I found this problem to be like very tricky for the first time. Okay. Okay, so this is there. This is now done. Note that for form 2, we can cache it across test cases. So this complexity is order n and not order n into t. Okay. Edit distance, very, very simple problem. Edit distance, similar problems we have taken up in the training too, in the workshop. How do we kind of model such problems where we have 2 strings and where we can add 1 character to the string, remove 1 character from the string and replace 1 character? How do we? Which form does this problem lie in? Form 3, okay. Yeah, everybody agrees on form 3, right? Multi-sequence, multiple different sequences are there. So it's very simply form 3. So love and movie, right? Love too much, watch movie. Love and movie. Okay. So we will start with these 2 characters, okay? So we'll try to find out whether we omit this or we omit this. So it's like if you add a character over here, if you let's say add a m over here to match with this, it's same as omitting this one, okay? So if you remove this, then you go to this one. If you add a m over here to this one, it's like matching this with this, okay? Or you can also do is you can convert this character into m, so it will be going forward in both of them. So the 3 transitions that are there is very, very obvious. One is like for a particular i comma j, you can like omit the first character, so it will go to i plus 1 comma j, okay? If you like add something in the front before the current character, then it will obviously be something that matches with the jth character, so it will be as if like you're omitting the j character now, because you have to match from this to this. So I to j plus 1, and then if you convert this L into M, then in that case you want to get into I plus 1 comma j plus 1, right? These are the 3 different options that you have very simply, and in this case we have to find out the minimum moves. All of these will contain a plus 1 cost, right? So with minimum across these 3 plus 1, that is what we need to do, okay? This is the edit distance problem. In this case L is going to be removed. Maybe like what we will do is LOVE MOVIE, okay? So in this case it's best to convert this L into M, okay, so that we move into both of these. Then these by default match. So if they by default match, then we don't really add a plus 1 over here. You don't need to convert. But if they don't match, then you have to convert. No, this plus 1 will be there conditioned with if they are same or not. Okay, if they are same, then we don't have. Yeah, if they are same, then we don't have the cost. Correct. So if this is same, then we don't have the cost. Okay, same, don't cost. So over here we add an I before it, so that this matches with this, so it will move into this one, and then we match this. So the transition is something like this. Once more, MOVIE LOVE, okay? First we convert M into L so that both of them moves forward, since there is a conversion plus 1. O and O, no conversion needed, and we can move forward in both of them, so we will go like this, okay? No cost added. VV same, no cost added, okay? Now for this, what we can do is we can delete this I over here, okay? In that case we can directly move to forward sense over here, so plus 1. EE match, no cost, we reach the end of both of them. then we're gonna get a 0 cost. So it's equal to 2. That's the optimal transition that will happen. Okay, very simple. If you have not coded like something like this before, just to show you guys how do you write codes like this in an actual sense. Would you guys be able to write edit distance in a neat way by yourself, or should I code this one? Batao? Should I code, yes or no? We can write it. Okay, nice. I was expecting some कोई तो बोलेगा. It's not as easy as you think. So we are getting the two strings and the lengths just to be sure. Okay. So what do we depend upon? I comma j in the previous transition graph. I comma j depends upon I plus 1 comma j, I comma j plus 1, I plus 1 comma j plus 1. So what should be the order of loops? Tell me real quick. What should be the order of loops? Very simple. Very simple. What should be the order of loops? N to 0, M to 0. Correct? That's perfectly correct. Both would be reverse. I equal to n, I is greater than equal to 0, I minus minus for integer j equal to m, j is greater than equal to 0, j minus minus. Okay. If I is equal to 0, I equal to 0, n, and m equal to n. Sorry, j is equal to m. Or let's say if it's or, okay, if it's or, if any one of them has become empty, what should we have the dp of I comma j as? If you can tell me this, I would understand that you guys have the clear understanding of base cases now. If I is equal to n or j is equal to m, what do we keep over here? When we reach the end of both the strings, in that case we only stop, right? So it's the base case is always after the end. So what do we write over here? Base condition bhul gaye. So one of them is empty. No, one of them is empty, other one is filled. So what should be the cost? One of them is, so if it's equal to n, then it's their, yeah, length of the strings, correct? N minus I plus m minus j. This is the value. One of them is going to be 0 and the length of the other string is going to be the current cost. Yeah, that is correct. Like what you are writing, Abhi, is actually correct, but I've just combined the statement in a single line. If any one of them is ended, then the other one has to be done with inserts or deletes. So it is just the length of that particular string left. Okay, this is the base case. Or else we're gonna compute the value of dp of I comma j. Okay, and in case we have, so I can write it in the same line. So I'm just trying to optimize the code more and more so that you guys learn more. You can obviously write it in separate if else and all. Yeah, we're coming to that. 1 plus this, 1 plus this. Okay, and over here dp of I plus 1 comma j plus 1, condition based on if, what is the two strings, a and b, right? If a of I is equal to b of j, if it's equal then cost is 0 or else it's 1. I've written compressed everything in a single line, which makes it difficult to read, but these are the three different options. If both are same, then you don't need any cost, and if they are not same, then you get a 1 cost. Clear everyone? True, we don't even need a ternary. This is also sufficient. But just to be clear, I'm keeping it over here. I mean, it will give us 0 or 1 by default. In that case, it would be not equal to this. Yeah, correct. But this is much better. Okay, so these are the three different ways in which we can kind of write the transition, and very simply the answer is going to be 0 dp of 0 comma 0. And we're done with the whole problem. That's all of the code for edit distance. Very short, crisp, and clean code, right? If you remember it. Clear? So short, right? You don't need to write much. Try to keep clean codes clean as much as possible by picking it up as much as possible as well. The more you see, the more you write, the more cleaner you write, right? So that's why I thought about writing this code. Okay, we're done with one more problem. Let's go to the next problem then. We're done with edit distance. Okay, rectangle cutting, clean code, nice. Next is we are rectangle cutting. We have to cut a rectangle A cross B into squares. What is the minimum number of moves required? How do we solve this? We can make any number of cuts, but we need to make sure that we get it in minimum number of cuts. And we have to make it squares, each piece. So how do we get it? Minimum side length. What do you want to do with minimum side length? Biggest square is equal to minimum of I comma b. That's not the best solution. So let me give you an example. Let's say we have something like 6 and 5. The biggest square would be of 5 length. So if you cut out a 5 length square over here, you would be left with 1 cross 5, and then you will need 4 more cuts, okay, to get 5 more squares, okay, and this is 1 square. The other way we can do that for 6 comma 5 is maybe something like this: 3 3 1 2 3 4 4 cuts. You can do it with 4 cuts, right? So it will not work. Greedy will not work in this case. We can horizontal or vertical cut both. Yeah, that is true. So in this case, we can do better than this. This is 3 3. This is 2 2. So 1 cut. So this is first cut, second cut, third cut, fourth cut. In this case, first cut, second cut, third cut, fourth cut, fifth cut. So greedy is not going to be there. Correct. Okay. And this is like paper cutting, but no straight rotation required. It's just going to return the minimum number of cuts. So we can keep, like, if you have to cut a piece of dimension x cross y, what is the minimum cut required? Okay. In most problems, if you are trying to see the problem and if you are seeing the problem for the first time, maybe throw everything that is there in the input in the parameters. If a dimension of shape x comma y is there, what is the minimum cut required to convert to square? Minimum cut to convert to square. Okay, and yesterday itself I think we discussed a transition for this kind of a problem, right? That if you have a piece like this, maybe you will make a first cut over here, second cut. So let's say this is x, this is y. Okay, so we can have first range of like kind of cuts like this, where you make a cut at a distance in the x side. So you are left with x minus a on this side. So what we will do is we will get something like this. dp of a and y is one dimension plus dp of x minus a comma y is one more square plus one cost to cut this way. Okay, and the other cost would be maybe to cut something like this. That would be dp of x comma some b over here plus dp of x comma y minus b on this side plus one more cut. So these are two different options. For different values of y you can range, for different values of x, a you can range in 1 2 3 up till x minus 1, a in the range x minus 1 from 1, b in the range y minus 1 from 1. Okay, and if at any point should a be equal to b, no, a and b are two different transitions. This is separate transition, this is separate transition. It is going to be min across all, and at any point in time if like two parameters become same, it is going to be it will return 0, because if the dimensions of the current sheet itself is like some a comma a, then you don't have to make a cost, right? It is by default a square, so you don't need to return anything, you don't need to cut anymore, so it will return 0. Okay, so it will by default return a 0 in that case. Clear, everyone? So let's write the code for this one. It's not that hard. We'll start from the smaller pieces and we will go till the largest pieces. Y is equal to 1, y is less than equal to 500, y plus plus, right? Integer. So if x is equal to y, that is the base case. In that case, dp of x comma y is equal to 0. You don't need to make any cut because it's already a square, or else we will try to make a cut. So integer, so in that case this is right now infinity because we have to minimize 1e9. For integer I equal to 0, for a is equal to 1, a is less than equal to x minus 1, a plus plus. What we can do is dp of x comma y is going to be equal to minimum possible with a cut at a distance on the x side. So that is going to make two different pieces. One is a y, x minus a comma y, and since we're making one cut we will get a cost of 1. That is currently, these are one of my options. Then we have a possibility of making a cut length on the y side. This is a separate transition. In that case x will remain the same for all the transitions and the y will change to b and y minus b. That's another option for us, and across all whatever is the minimum we will get that. So this is the whole code. Finally we need to do it for n cross m, whatever is the input. Let's say n cross m. That should be the whole code. Okay, that should be the whole code for this particular problem. Looping through, where do we make the cut in the whole piece so that it breaks into two different pieces of a cross y and x minus a cross y. That is what is happening over here. Clear, everyone? How do we code such problems? Can I have a quick +1 if this is clear? And like always a bigger piece depends upon smaller piece, so we are going from smaller to larger side dimension. Okay. Great. Okay, so if you have not yet liked this stream, definitely hit the like button, and we're gonna move to the next few problems left that is there in the problem sheet. So we are done with rectangle cutting as well. Money sum. This is also very straightforward. I've already solved this problem in the whole series. Tell me the problem which is very similar to this one. There were queries. Which problem did we solve in this case? Very similar to this one. There are n coins. Your task is to find all money sum you can create using these coins. We have solved something similar before in the DP workshop, which problem? If any one of you can understand, then I would say that it's fine. We can kind of relate it to that, or else maybe I will have to explain it again. Which problem? Tell me the day and part maybe, or any problem that you remember. Knapsack with queries. It was not really knapsack, but there was one problem. There is something called subset sum with queries, right? So we have to create a subset with a particular sum. This is just subset sum, but with queries, you have to find out for all different answers. Yeah, that is correct. This is just subset sum. This is not like, it's similar to knapsack only, but it's subset sum only. So what we do, we write as a DP for this is in form 1 is DP of I comma sum. What is the sum left to create? Okay, and from this we can, like, you are going through the items and the ith item is over here. What is the sum that you have to create using the rest of the items? If you take this item, then you will have to make DP of I minus 1 comma sum left minus a given taken value. Let's say this is x. If you don't take it, then sum of I minus 1 comma x, sum left. Okay, if any of them is true, then this is also true, so you can make this much of sum left. Okay, so simply just compute this DP using an OR across all of the things, and then DP of 0 comma any x will tell you can you make x using all the elements, yes or no. So that's the transition for this particular problem. We have solved the same problem in the workshop. You will find it on day 2, part 2 and part 3. Okay, in fact I have solved it for the query version of the same as well, with printing solutions too, so you can check that out so that you can kind of understand this. We check for 1 to sum if possible and count. Yeah, that is true. Okay, this is one way in which you can solve this problem. You can try to solve it in other way as well, like maybe you can do it with form 2 too, that can you make some value x. Okay, and to check if you can make value x or not, in that case you can kind of go through which one would be used last and then make a transition and try to create that. It is also solvable with form 2. Both of them would be fine. Okay, there is a very neat way to solve this problem. Do you guys want to see a very neat way to solve this problem, a very optimal way to solve this problem? Please let me know. Do you guys want to know a very optimal way to solve this problem? Divide and conquer? No, not really. Maybe you can do that, but I don't really want to get into those. Okay, let's see. So since you guys are in my stream, most probably let's learn something interesting too. Okay, yeah, counting tower was something already covered. So let's learn something very interesting. Okay, so what is the maximum value of the sum that can be created using the given constraints? What is the maximum sum you can create? Just tell me real quick. Total plus sum. What is total plus sum? Or you mean to say sum of xi's, which is on the worst case? Ten to the power 5, right? We can always make the sum 0. Okay, we can make the sum 0. That's it, that's the whole code. For integer I equal to 0, I is less than, let's say Um let's see if this works. Four, 4, 2, 5, 2. Yeah, so we get the same thing. We don't count the zero thing over here, so we can remove the zero separately, but we get the same set of numbers, right? Over here. Makes sense. What magic did this do? What is this witchcraft which is solving this problem? Okay, what is this happening? Okay, so what we are maintaining in this temp is, what are the, like, after every iteration, like it is telling us what is the, yeah, which sums can be formed, correct? So initially we are maintaining something like this, 1 0 0 0 0 0, let's say, okay, something like this. Okay, so it says that 0 can be formed, 1 cannot be formed, 2 cannot be formed, 3 cannot be formed, 4 cannot be formed, 5 cannot be formed, 6 cannot be formed. Okay, let's say you get a 2. Okay, let's say you get a 2 now. So what we do is we shift it with 2 positions and then take an OR with itself, so it will convert to 1 0. If you shift it with 2 places, this is going to be over here, so you will get 1 0 0 0. What is this telling me? What are the numbers that you can build with just 2, okay, and 0? So these are the two different possibilities. Now let's say you get a new number 3. You shift it with 3 positions, so this gets over here 1 2 3. So this is over here, and then shift it by 3 positions, 1 0 1 0 0, something like this. This will get truncated. So, and you take an OR. So you can see that with 2 different elements you can get 0 2 3 and 5. What is happening over here? What is happening over here? Think about it. What we are essentially doing is, we are, like, whatever we can form previously, we are adding this 3 to all of them and adding them to the current set of elements. That's what we are doing. Whatever we can form, in all of them we are adding the new element we got. Like, it can be either like whatever you had taken earlier, or maybe adding 3 to all of them, right? New set. So just include 3 in all of them and then take an OR with them, like both of them are feasible. So that's how we are kind of doing it with bit set. And this is very, very, like, crisp code to do the same thing, to maintain which all subsets are possible to be created using bit set. Okay, and this is one of the most optimal ways maybe to do this. Here everyone? If you don't know bit set and stuff, so I guess then this will not be possible, but I hope you got the DP idea at least. Okay, let's move to the next problem. This problem we have already solved. Can I have a quick +1 if you guys agree that I have already solved this problem? This is same as the DQ game problem from AtCoder. How many of you remember? This is the exact same problem from AtCoder, which is called DQ game. This is the same problem. We have already solved it in the educational DP of AtCoder. So go ahead and check that out if you have not seen it. There is a very nice idea in that one. So definitely check that video, the AtCoder video. But we have already solved this in the AtCoder video. Okay. Okay. This is there. This is like, you have to find the number of ways you can be divided into 2 sets such that they have equal sum. This is also very, very simple, straightforward. One of this, like, you have to make a subset sum of total sum by 2, right? So what we need to do is, we need to divide 1 2 3 4 up till n into 2 sets such that the sum is equal, which means each of their sum is nothing but n into n plus 1 by 4. Right? So what you need to do is, you need to find a subset whose sum is n into n plus 1 by 4, which is nothing but the subset sum problem. The same thing that we have solved many times now. Like, find a subset with a given sum. We have already solved this particular problem in the practice. Same question is over here, exact same thing. So make sure that you check the day 2 part 2 of the videos that covers this particular concept. Okay, given a like set of numbers, find out a subset which sums up to a given number. It is already solved in day 2 part 2. Okay, so we have already solved this particular problem as well. You can try and do that. This problem also, have we solved this particular thing? Have we solved longest increasing subsequence already? Yes or no? Can you guys find the LIS in log n? I mean, this is just finding the length. I've also showed you guys how to solve it and find the actual LIS. Okay, by just going through in the backward fashion in that particular code, right? That is even one step further from what is being asked right now over here. N log n, finding, printing, and then using it even further. So I would like discuss all those versions. This is also covered. The only problem that is left is projects. Okay, this is, I think, this like first or second most hardest problem in the standard series that you would be getting. For each project, you know the starting and ending date and amount of money you can get as a reward. To only attend one project during a day, what is the maximum amount of money you can earn? How do we solve this particular problem? Okay, how do we solve this one? You need to solve it in n log n. It's like knapsack. I mean, it's sort of knapsack, but like the intervals should not overlap. So there is a problem over there, that there is an like interval overlapping issue that is kind of happening. Okay, the intervals. So you have to find out a set of ranges. So each element is a range, right? You can do only one project during a day. So every element, every set that you choose should be disjoint in the number, in the days that it includes, right? So what is the best you can do with that? Okay, how to solve this? It's actually a very neat problem, and this is the last problem that we will take for today. Sort by start time or by end time, any one of them, that is correct. That's a really good idea. Sorting plus dp of level last taken. Last taken, if you keep in the state, then that would be very large, right? 10 to the power 5 plus 10 to the power 5. You cannot do that. Sorting makes sense, but keeping last is very difficult because it can be up to 10 to the power 9. Sort by start time, okay, that is fine. But what after that? So what we can do is we can sort it by start time. Okay. So if you sort it by start time, this will be my segment 1, segment 2, segment 3, segment 4, segment 5, segment 6, segment 7. Okay. So we sort the segments by their start time and end time. Okay. Now what we do is we go through each segment one by one. So we start with segment 1. We again decide it in the form 1. So we'll solve it in form 1 itself. Do we take this or not? If we take this, then we cannot take anything till the point where the ending state is happening. So we will find out the first segment which starts after this endpoint and do the best we can do after that. So whatever best we can do from the fourth element, try to get that. You cannot take, if you take 1, you cannot take 2 and 3. Since the starting points are sorted, use a binary search to find out which element next we can take, and from there you can take all the elements going forward. So solve that particular sub problem. Or else the other option is that you don't take it and you move to the next element directly. That's the main idea. Okay. So first I will code it and I will explain it again. The coding part will make it more clear. That's why I'm trying to code it first. Okay. Integer n, scene n, and what I think we have is 3 different things. So we will keep something like this: pair of pair. So we will get, let's say, the LR integer LR start end and the start and the P, but we need what was the last taken. No. So if we decide that this is taken, then we know that we cannot take anything till 3 and we can take everything from 4 and beyond. So we'll directly jump to 4. So we don't know what was last, we don't need what was last taken, because we know everything can be taken beyond 4. So we directly jump to there using binary search. I'll show you. I hope the input is given in this way only. If not, then we will like obviously parse the input AI, BI and PI, start, end and reward, and start and day are included, right? I'm assuming that the start and end dates are inclusive of both the sides. So what we do is we keep ARR of I is equal to, we keep the ending, the start date over here, and then the ending date and the price we keep over here. Okay, this is something we can keep here, or you can also use this hash define MP make pair, and ideally you should do it this way. Okay, and then what we do is we sort the values, sort ARR of I, ARR comma ARR plus n. Yeah, we find out the current best next. The way we do it is we go through all the elements. So for integer I is equal to, we go from the last element to the first. We will create something like that. Okay, so we'll go from last to end. Obviously, like, so we are like going in form 1. So if you reach the n, if I is equal to n, and then you have processed all the segments, so you cannot get any more score, so you will return 0. So sorry, dp of I is equal to 0, right? Or else we will have to compute something. So there are two options. Take it, integer answer equal to 0. Okay, so first thing is you have an option that you don't take this element. In that case, you can easily go to dp of I plus 1. You just omit this particular element. Okay, or else if you take, then the next element you can take is from integer next val is going to be equal to this, like, r that we are getting over here. So ARR of I dot second dot first. Okay, so we need to find a particular segment which starts just after this thing. So what we will do is we will do lower bound, or sorry, upper bound. Okay, so auto IT equal to ARR, or we will find out the first index which is strictly bigger than this particular value that is given over here. So the way to find that is ARR of lower bound on the array ARR, okay, with something over here and 1e9. This is very, very crucial over here. I'm going to explain what I'm doing over here. 1e9 minus ARR. This is the next index. This is the next index. What did we write over here? Okay, if you take it, this is something related to binary search. If you take it, then you cannot take till this particular point. So whichever, like in the array, whichever segment starts after this endpoint, so r comma infinity. So the next element is guaranteed to be having L bigger than r. Okay, don't put over here as 0, because then it will include things that will start at r. So this has to be infinity to get a strictly upper bound. Okay, so when you are doing, sorry, this had to be upper bound, I missed it. I'm saying upper bound, but I'm writing lower bound. Magic. So when you do upper bound, make sure that you put it as 1e9. If you do lower bound, minus 1e9, 1e9. Okay, that's how we could keep things when you are doing like binary search on pairs and stuff. So we keep this way, and you find out like the first element which is strictly bigger than the current element, minus ARR will give the index to that, and we do answer equal to max of answer comma. If you take this element, you're gonna get the ARR of I dot second as the reward for this element, plus the best you can do from the element that is beyond the next element, like that is beyond the element that is what you can take. So that is what we are kind of keeping over here. And I mean, this is nothing but dp of I only. And we are done with the whole code. That's the whole problem. The only nice idea is to sort and use this binary search to optimize the transitions over here, which is very like non-trivial. I would say this is a non-trivial problem. You'll have to know how to solve this problem, but this is like I would say like a very elegant way to solve the problem, which is weighted interval scheduling kind of problem, right? Where you have weighted intervals and you have to find out the best cost. So this is the way to solve this problem. Okay, you always find out which, like, if you take this, then you find out till which you cannot take, and then find out the first element which is starting after that. Since it's sorted, everything after that can be taken, so you go till that point and find out the best you can do beyond that. That's what we are doing over here. Okay, and that wraps up almost all the problem that we have. Let's quickly see if it's giving us correct value or not. What if it's giving me wrong value? That'll be magic. I have some typo maybe. R is not declared. That is next. It should be next val. More issue. Let's see what is the issue. Did we use hash define int as this? No. Okay. Oh, this is float, right? We'll use something like this. Zero 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 zero. So that's 10 to the power 9. So you cannot like create a pair which is not really of similar types as what is being used to insert. Or what is the type of the ARR? You cannot use something beyond that. Okay, so we're getting the answer as 7 only. Okay, yeah, integer 1 9 will also work. That is correct. Make sure that you will have to also put things in long because this DP array has to be a long value. Okay, because we are adding things up over here, so we need to make sure that it is long good enough to kind of find out the answer. Long. That's it. Yeah, that should be all that is required for this problem. I mean, nothing more than this will be required for this one. Okay, so we have almost solved all the problems. Only 3 problems are left, 3 different ideas. We will cover one of them in the next one video, which I'm going to make and upload. Okay, but almost all different ideas are covered. How to binary search in complex structures? Like, what do you mean by complex structures? Like this vector of pairs, do you mean? Yeah, so you need to, so it will always be searching on the first value only, but if the first value is same, then it will compare with the second one. So you can only do it with first value itself. Okay, so we are finding out the first value which is bigger than this next value, and then you need infinite value over here, infinite to put it to the next one only. So it's just how pairs are compared, but you need to find out the one bigger than this one. Okay, so that's how this works. Okay, so that is almost there. So try to run this code with different examples and you will see how this works. Okay, upper bound, how this works with pairs or pairs of pairs, right? So that's almost all the problems. By default it checks the greater than condition. Yeah, correct. Cool. How to be good at 3DP problems? Practice definitely, but there are multiple different sub ideas which are repeatedly used. Like the 3 that I generally teach are things like in out DP, then there are knapsack on DP kind of optimization are there, and then there is ancestral DP on top of 3DP. So mostly all problems are either of the 3 that I've seen till good amount of level, 2400 level. Maybe someday we will learn these things, but for now this is what we do for DP workshop. Covered a lot of things, right? Do you guys want to have a quick recap of every idea that we discussed in the CSES problem set? Should we do that? Yeah. So comment down below. So make sure that after the video, like, comment exactly what do you need. I will put the resources in the comments. Okay. Can you explain basic idea of knapsack? So mention me these things on the comments. I will add the links to those, because now if I send it will get lost. So no problem. And I will have to find it now, right? I will find it and give you guys in the comments. Okay. Anyways, I've added the two things that you had requested, Sivang. The previous, like the editorial for knapsack twist is added now, and editorial video, and the problems, the monotone DQ idea is also added, so you can check that out too. Okay, cool. So let's quickly go and do a quick recap if you guys want to. Should we do a quick recap of the main ideas, or are you guys already bored? I'm not able to submit. Okay, that's weird. So make a post on, like, make a comment on the video that what is the problem. I will get it resolved if there is some issue. Should not be a problem, but let's see. Not sure. Okay. It might be vision issues. I'm not sure. I have to check once. Okay. Let's quickly go through dice combination, minimization, combination 2. Very quickly we're gonna go through the problems. Okay, just rapid fire. Okay, so 6 different options, and we need to reach a particular, like, sum, the number of ways. So this is form 2, and we just think it like the way that we are standing at level 0 and we need to reach level n, and we can make a jump of 1 2 3 4 5 6. So it's a staircase, climbing stairs problem itself, just translated in a different way. So the transition is form 2, and we are just doing it in a standard way. Coin change problem, we have to find out the minimum number of coins required. So that is also coin change problem, but it's just that now we are finding the minimum number of steps, minimum number of jumps required to reach some level. Very same problem, form 2, direct solution for this one. Coin combination, again we need to make a coin n using a predefined set of moves. This is again stair climbing problem with a predefined set of moves that you can do, and you have to reach the stage n coins. What are the different number of ways in which you can reach that? Same problem, just in disguise. Everybody's just disguising the same things. Okay, the other thing is coin combination 2. This is a good one because we need to make sure that we generate things in a distinct ordered way. So in that case, we try to generate things in a sorted way. Okay, so we generate all 2s and 3s and so on. So the idea was to maintain the level and not go forward if you are taking the item. Okay, so that was the 0 1 0 infinite discussion we have done in the previous video, in the part of the videos. If you want, you can go back and check that. Okay, subtract 1 digit, very simple. Keep the current number itself in the state and or iterate through its digits to find out the different transitions that are possible. Okay, that's the problem for that one. This is like, I have already coded a very neat way to do this, like finding out the number of ways to reach the endpoint, adding the 2 different moves, and then replacing it with 0 if it's a star or a hash, whatever that is. Right. Then in a bookshop, this is nothing but a knapsack problem, just in disguise. So we have already solved this one. We have n integers between 1 to m. Absolute difference between them should be 1. This is a very good problem. I have solved this one before. Keeping track of the last element is very important, and for every interaction between 2 elements, you keep a dependency on the last element. That's how you solve the problem. Okay, and we go through all the elements and understand the, like, if that element is fixed, then you have only a single element range, or else the range is from 1 to m. But if you know the last element, you have only 3 different valid transitions. So according to that, it would be n into m into 3. That's the total time, obviously. Okay, next is this very beautiful problem, counting towers problem, in which we had a nice idea that what is the last one? Is it an empty part? Is it an empty part like this, or is it a dashed thing? Based on that, we make a transition, that what do you need to happen behind this, from n with a dash, making a dependency on n minus 1 of a dash or n minus 1 of an empty, things like that. So that's how we write the, like, code for this one. Rectangle cutting, we already talked about this. Like this is similar to the paper cutting problem we have solved previously in the doubt sessions or even in the videos, that we make the cut at a particular point and divide it into two different papers of different sub problems. So that's how we do it, and we iterate over all different possibilities of cut that we can do on a paper. Okay, greedy will not work in this case. I've already proved that with an example in the video. This is edit distance, simply form 3, very simple. Edit delete I plus 1 j, I j plus 1, and I plus 1 j plus 1 plus whatever, depending upon the character matches or not, right? Next is you have n coins and certain value. Your task is to find all money sums you can create using this. We solved it in multiple different ways, very standard subset sum problem, but we can do it with bit set as well. We talked about that particular solution. Removal game, this is the same problem as the problem of DQ game in AtCoder problem. So I've already solved it before, so I did not really take it again. If you want, we can, this is an LRDP problem, so it's a order n square LRDP problem. Okay. Coming to your question, Chetan, at the end. Okay. This is divided into two sets. So we know that when we have to divide the whole number into two sets with equal sum, we know that the sum of each part is nothing but n by 2, the sum by 2, n into n plus 1 by 4. So we have to find out a sum with a given sum. We have to find a subset with a given sum. Same problem again, but it's in disguise, just in disguise. Increasing subsequence, it is finding the alias of a particular sequence, and in the workshop I have already uploaded a dedicated video on alias in nlogn and how to even print the alias in nlogn if you want that. Projects, this was the last problem that we took up. A very beautiful problem in terms of how do you use form 1 in such a problem where there is an interval checking that happens. Sort by starting point, and if you are taking something, binary search on which is the next thing that we can take and go forward from there. That's what we use in this problem. Okay, so that's almost all the problems in the CSES set that we can solve. Elevator riding and tilings are like bitmask DP problems, and counting numbers is digit DP. We will do the counting numbers anyways in the videos that I'm going to upload in few days, but that's almost all the problems that you can solve in CSES. Almost all the problems are solved now, right? So that's full solution. Okay. Now let's take some questions. Broke, I can take DSA. I can solve DSA problems, but unable to solve contest problems. How should I proceed? I think while you're practicing, you're not practicing them like contests. That's the biggest problem that people make. I see that people don't solve practice questions in a contest setup, as if you are solving it in a contest, in a time-simulated way, in a proper way, sitting down and coding it in a nice way. You don't see a tutorial unless it's required and things like that. That's another thing. Okay. So one more thing, like if you guys can maybe, if some of you are gonna like revisit the video and just want to help me create more such content, if you ever want to do this one, just maybe help me with like creating the time stamping of the problems maybe at some particular point in time. That would be very helpful. Maybe I'll try to take out time, but I have not really created for any one of the videos yet, so I will see. So that's almost all the problems on the CSES set. What else should we do now? Any ideas? Anything that you guys want to do? So aptitude problems for placements. So CAT. So you can search for CAT problems. So aptitude problems in general for placements are very similar for CAT problems. Mental ability or problems. There was this NTSC which used to happen where we had mental ability test. Those questions, or for CAT there is like aptitude problems available on internet as well. You can search for the same and practice those. Okay. Is contest important? So code for this contest is not really important for jobs, at least. Lead code weekly is more than enough. You should try and do really well in lead code weeklies. That should be very important. That they are very close to coding tests or even sometimes questions in interviews. But code forces contest nowadays that happens don't really resonate with the code like interviews or coding tests that happens. Okay, if you're doing it for coding tests and jobs. Okay, sure. That's a very long stream, almost 2 hours plus. How many hours did we sit for? 2.5 hours most probably, right? I think OAs are harder than you think. It's definitely true, right? Which college you are in and which year? I'm already graduate, guys. I'm working at Google right now. Okay, chalo. I think that will be all, guys, for from my side for today. We will see more such problems. We'll kind of keep learning more and more things. The channel will keep having more and more content. So make sure to subscribe and keep the bell icon pressed. Right, that's there. With when will cadence to twist other problems will be solved? Cadence twist. I've uploaded the video. Right, I said the video tutorial is uploaded now. Okay. Maybe we'll have a doubt session some with some time after some time, but you can try and solve the problems by till that particular point in time. Okay, we'll have some doubt session after some time during the end of next week, maybe like Friday or so. Okay, but almost all the content that was supposed to be uploaded by the DP workshop in the DP workshop are now uploaded. So it's now your task to kind of solve the problems. If you're not doing it now, then it's up to you. It's on you now. I have made sure that I delivered whatever I thought of. Okay, now it's up to you to kind of complete things up. But milk against twist. Okay, you think AOAs are harder? They are harder. It's a fact. Okay, chalo. Thanks then, guys, for joining in. I hope you guys enjoyed solving so many problems. Okay, many different ideas, many things to be covered. I mean, I hope that you guys go through the video maybe one more time when you're like solving them on your own and then get it covered up. Okay, we'll meet in next some other live session, some other live stream, some other video, and we'll cover more and more problems. Okay, and obviously more content is gonna come soon. Okay, see you all then. Chalo, bye bye everyone. Thanks for joining until this particular point in time. 15 people at this stage. Too much. 2.5 hour stream. That's very difficult to sustain. Shivang has been like there for a very long time. Really nice. चलो जिम फ्लेक्स है क्या जिम फ्लेक्स कहाँ है देखो ये जिम फ्लेक्स है चलो I think that will be all. Now I'm gonna go and play some games. You guys also play and enjoy. ठीक है bye bye see you all. Games बोलो तो ऐसा नहीं कुछ बड़ा गेम खेलूंगा. I'm gonna just play normal games. Maybe I'm gonna call a few of my friends and say let's play Smash cards. Chalo, that will be all. Bye bye everyone. See you all in some other stream. And keep learning, guys.